Hi there, my name is Dimitris Haralambidis, and in this video, which is actually one of my videos on series of transformations, we will discuss about a special case of transformations, the one of reflections. So far, we have seen together the translations which occur when we add or subtract, when the change occurred on the graph is described by either addition or subtraction. We have also seen dilations, which occur when we have multiplication or division. So what's left? It's left to describe what happens when we multiply by negatives. So these special cases of multiplying or dividing by negatives can be seen as graph deflections. So let's start by placing a proper title, graph reflections. And let's begin by the fifth case in our series of transformations, which is the one from f of x turning to minus f of x. Although with the knowledge we have already, we could describe that as we could describe this as a vertical dilation of factor -1. However, we don't do that, and we go by a reflection on the x-axis. And geometrically speaking, this means that if this is the graph of f of x, this should be the graph of minus f of x. Remember that the negative sign can be described as a reflection, and if the negative side is outside, is in the output, can be seen as a reflection on the x-axis. And this will help us actually describe any presence of any negative sign. For instance, for example, if we have f of x moving to minus 2f of x, instead of just saying vertical dilation of factor -2, we will do the description in two stages. In stage 1, we will describe the dilation with the positive sign. So we will say that this is from f of x to 2f of x. This is a vertical dilation by factor 2, which is then followed, and now I'll put the negative sign, which is followed by a reflection on the x-axis. So remember, instead of directly saying vertical dilation of a negative factor, you should do vertical dilation of that positive factor and then reflect it around the x-axis. As per instructions now, because we have repeatedly mentioned that any description of any transformation is a set of instructions, as per instructions, we would basically now do the opposite. We will follow what the vertical dilation suggests. So in this case, it is a vertical dilation by factor. It can be seen as a multiplication on the y by something negative. So this specific one would have meant multiply, which has to do with the dilation part, the y of the point, the y coordinate of the point, by that negative number. So, for example, in the transformation from f of x to minus 3 f of x, the random point with coordinates x, y would have been transformed at x, negative 3y. In f of x moving to minus 10 f of x, the random point with coordinates x, y would have moved at x, negative 10y. And finally, let's finish our series of transformations on the last case. Case 6 is the one that takes f of x and moves it to f of minus x. Here as well, instead of saying horizontal dilation by factor -1, we rather say, a reflection to the x-axis. Geometrically speaking, this means that if this is the f of x, then that would be the f of minus x. And again, when we have, apart from the negative sign, the presence of a number as well, we, as in this example, from f of x moving to f of negative 2x, we do the description in two successive stages. At first, we describe that without keeping in mind any negative signs. So we see from f of x to f of 2x, which is a horizontal dilation of factor 1/2, which is then followed by a reflection on y-axis. And as per the connection between the xy, this means multiply just dx, because it has to do with a horizontal transformation, by -2 in that case. Not by -2, by -1/2. So it should have been -1/2 x, y. That's all as per reflections. I hope my video does make sense and helps you in understanding further what reflections actually are. We will continue with at least 2 new videos on transformations. However, so far, if you have any questions, either in this video or in the previous ones, please let me know. Feel always free to leave your comment below each one of my videos. As always, thank you for your time.